All right. This is test 1 review. This is over chapters 1, 2, and 3. And we are looking at chapter 1 stuff first. And for chapter 1, it says in problems 1 through 3, classify the variable as qualitative or quantitative. If the variable is quantitative, state whether it is discrete or continuous and explain. So number 1 says number of new automobiles sold at a dealership on a given day. All right, well, when I see the word number of, then that automatically will tell me this is a quantitative variable. So I'm going to say quantitative. Because it is numerical. And then, is it discrete or continuous? Well, if I can count them, if it's countable, right? If I'm counting number of new automobiles sold at the dealership on a given day, then this is going to be discrete. So discrete because it is countable. Okay, weight in carats of an uncut diamond. Well, if we're talking about weight, again, that's a number, so I'm going to say this is quantitative. Quantitative, because it's numerical. And this one, because it's the weight, we can take weight down to as small of a measurement as we want, right? So there are, all the decimals make sense here. So in other words, this one's going to be continuous. Continuous because it is a measurement. Okay, brand name of a pair of running shoes. Well, oh my goodness, what just happened? All right, because we're talking about the name of something, this sounds like this is a qualitative variable. Qualitative. Hard word to spell. Qualitative because it categorizes. My goodness. Categorizes by a certain quality or characteristic. Well, no, I don't want to say that. Characteristic. Period. Okay. In problems 4 and 5, determine whether the underlined value is a parameter or a statistic. Explain. Okay, remember parameter is a numerical representation of something for a population, and a statistic is a numerical summary of something dealing with a sample. So in a survey of 1,011 people aged 50 or older, 73% agreed with the statement, I believe in life after death. So when it says in a survey of people, well, this here tells me that this is going to be a sample, okay? So in other words, because we have taken a sample of people here, then this number is going to be a statistic. So we would say statistic because it represents a sample. Okay. In the 2015 NCAA football championship game, quarterback Cardale Jones completed 70% of his passes for a total of 242 yards. So, would this be a parameter or a statistic? Well, let's see here. It says we're talking about one championship game, and is saying that he completed 70% of his passes for the whole game, right? So the whole game is the population. This one's a little bit of a tough one, but this number here is going to be a parameter parameter because it represents a population. And the population would be all the passes in the game. I'm going to put all passes completed in the game. Actually, I'm just going to say all passes. No. Completed in the game. Okay. Well, that's it for chapter 1 stuff. So chapter 2. This is where we were talking about how to organize all of our data. So it says use the following data for problems 6 through 9. A random sample of 60 couples married for 7 years were asked to give the number of children they have. The results of the survey are as follows. Construct a frequency and relative frequency distribution of the data, round to 2 decimal places as needed. Okay, so I put a little blank table here for you. What I'm really looking for on the test is that you label your columns correctly. So here, when we're talking about what is our data, so this is our data over here, right? These are all of our x's. And what do those numbers represent? Well, if we come back to our problem here, it represents the number of children that they have. Okay, so when we fill in our table here, we're going to say number of children. We're going to find the frequency, which you can abbreviate with just the letter f, the lowercase f. And then it also says to calculate or find the relative frequency. So relative frequency here. Okay. So number of children. So we need to go through our little table here and we need to identify all the numbers that you see in the table. I see 0, 1, 2, 3, 4, 5. Is there anything more? Do I see any 6s? No, it looks like 0 through 5 are our numbers. So 0, 1, 2, 3, 4, and 5. Okay. Once you do that, then you need to go through your table and you're going to count all the zeros that you have. You're going to count all the ones that you have. You're going to count all the 2s and so on. Right? Well, I'm going to tell you what those are. I'm going to tell you also on your test you won't have 60 data, a set of 60, maybe something more like 40, but you're just going to go through and count. So the number of zeros, I'll show you how to do this. 1, 2, 3, 4, 5. Oops, hold on. Okay, so, sorry, where was I? 5, 6, 7. So it looks like there's 7 zeros. So I'm going to just put a 7 there for the frequency. Then you'll do the same thing for the 1s, the 2s, and 3s, and so on. So you'll get 7 1s. You'll get 18 2s. You're going to get 20 3s. 7 4s. There's 1 5. Okay. Now, the way you can verify if you got them all is to add up your column here, right? Add up the frequencies and it should total 60. Okay, now this, right up here, this tells you 60 couples. That's how many they interviewed, right? So when I calculate my frequency here, what is that? 21, 22, 22 plus 18 is 40 plus 20 is 60. Yeah, so this adds up. The sum of the frequencies is in fact 60. Okay. Now, for the relative frequencies, in order to calculate that, you're going to take your frequency, you're going to divide it by the sum of the frequencies. So in other words, 7 divided by 60, 7 divided by 60, and so on, right? Now, I believe these are going to have to be rounded numbers. So 7 divided by 60 is, yes, going to have to be rounded. That's 0.116, and so on, lots of 6s. And that one actually doesn't need to be rounded to 2 decimal places. It's 0.3, but I decided to go ahead and add the 0 there. 20 divided by 60 is 0.33. We already did 7.12. And then 1 divided by 60 is
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44, a complete AI creation platform. Describe what you want, and watch it take shape. You can plan,
is 0.02. Okay, now if you were to add all of these numbers up, it should total somewhere pretty close to 1. Because you have rounding errors, it may not equal exactly 1. It may be pretty close. Let me see here. Yeah, in this case, this totals 1.01. So it's like really close, off by 100th. But that makes sense because of the rounding errors. Like some were rounded down, some rounded up, and some exact. So anyways, this is it. That's all you have to do for number 6. Number 7 says, what percentage of couples married 7 years had exactly 2 children, round to the nearest percent? Okay, well, the question asks us for a percentage, and it says exactly 2. So let's go back. Okay, let's look. Okay, exactly 2 children. That's this column right here. I'm going to highlight this in red. Maybe I'll do orange, actually. Okay, so there's exactly 2 children, right? So if I take my relative frequency and I round that, and I convert that to a percentage, that's going to give me 30%. Okay, so 30%. And that's all you have to do is just go back and read it, okay? Number 8 says, what percentage, again, percentage of couples married 7 years had at least 2 children. Okay, at least 2. Round to the nearest percent. Okay, so at least 2. Okay, what does that mean, at least 2? Well, that means 2 or more. Okay, so let's come back here. So 2 or more. So that's all of the things down here. 2, 3, 4, 5. Right? So I can add all of these up here. Or if you want to, you can add all of these up here and divide that number by 60 and give a percentage.